Solve the system for x, y, and z. Again, I'm going to be using elimination. And let's get started by numbering the equations, because that would be making things simpler for us to remain organized throughout the whole process. And my strategy will be to eliminate one of the variables by combining equations 1 and 2, then eliminate that same variable combining 2 and 3. Then we can go from there. Okay, so equation 1, I want to multiply by 2 so that I have a 2x here and a 2x down below when I combine it with equation number 2. So let's do that. Multiply equation 1 entirely by 2. So x times 2, 2x, negative 2y times 2, negative 4y, z times 2, 2z. And negative 9 times 2, negative 18. So that's equation 1 multiplied by 2. So equation number 2 will go down below. So how can I eliminate 2x in this case? Rather, just eliminate the x's. I will be subtracting these equations. 2x minus 2x will cancel out. Then negative 4y minus y will be negative 5y. 2z minus negative 3z is 5z. How did that work out? Negative negative makes a positive, so 2z plus 3z, 5z. And over here, negative 18 minus negative 3 is just negative 15. Because negative 18 plus 3, negative 15. Great, so I'm going to call this equation number 4. And I'll leave it here for now. Now I'm going to combine equations 2 and 3. I also need to eliminate x, otherwise my system here won't work. And to do that, I'll multiply equation 3 by 2, so that I also have a 2x, so that I can cancel things out once I combine equation 3 with equation 2. So actually I'll just write equation 2 up top here first. And multiplying equation 3 by 2, you get x times 2, 2x, 4y times 2, 8y, negative 2z times 2, negative 4z. That's equal to 24, which is 12 times 2. Okay, so I need to also subtract these equations to eliminate 2 x's. Okay, so 2x minus 2x cancel out. Y minus 8y, negative 7y. Negative 3z minus negative 4z is just z, because negative negative make a positive. Negative 3 plus 4, 1, so 1z. Finally, negative 3 minus 24 is negative 27. Great, and that is equation number 5. Now I want to combine equations 4 and 5 and eliminate either y or z. Before I get started, though, I noticed that in equation number 4 we have a bunch of multiples of 5, so I'm just going to divide everything by 5. That'll make things simpler. So negative 5y divided by 5, just negative y. 5z divided by 5 is z. And negative 15 divided by 5, negative 3. Great. Now let's put this equation, which is 4, down below. So we get negative y plus z equals negative 3. Then we can subtract the equations. So negative 7y plus y is just negative 6y. Z minus z cancel out. And negative 27 plus 3 is negative 24. Y plus, because negative negative make a positive. Now I can divide both sides by negative 6. And negative 24 divided by negative 6 is just 4. Excellent. Now that we have y, we can solve for z by plugging the 4 into this equation right here. We could also use equation 5, but that one's easier. So let's go with that. So negative 4 plus z equals negative 3. Now I can add 4 to both sides of the equation. And z is going to be equal to 1, which is negative 3 plus 4. Great. Now we're just missing x. And to find x, I will plug both z and y into equation number 1. So equation number 1, x minus 2y, and y is 4, plus z equals negative 9. So x minus 8 plus 1 is negative 9. Negative 8 plus 1 is negative 7. I can add 7 to both sides of the equation. And x is equal to negative 2. Excellent. So our answer is, that was unintended, the little line there. The answer is negative 2, which is x, comma y, which is 4, comma z, which is 1. Final answer.